So this is the second video of Catch-Up, and we're going to look at acceleration conversions. Basically, how to calculate acceleration when the units don't agree. So, quick refresher, in the last video, you spent time using this equation, the basic way to calculate acceleration. And your units typically are things like meters per second squared, which is meters per second per second. And as we saw in the fall, if your units do not agree, meaning the two velocities are not in the same unit, or if you have a velocity and an acceleration and they're not in the same unit, you need to take the time to convert so that everything is in the same unit. So we're going to do some practice problems primarily in this lesson. So practice problem number 1. You should get out a calculator and pencil and paper and do these as we go along. Don't just watch, actually do them. So in the earlier video, we calculated the acceleration of a cheetah. And I believe we found, I can't remember. We had a cheetah that could go from 0 kilometers per hour to 96 kilometers per hour in 3 seconds. And if we do this, we find that the calculation showed us that the acceleration was 96 divided by 3, so 32. And the units were kind of weird, kilometers per hour per second. So in this problem, I want us to convert kilometers per hour per second to meters per second squared. So we're going to convert (32 kilometers per hour per second to meters per second squared. So like we always do with conversions, set them up left to right, where you have a start quantity. Actually, I'm going to write this a little differently. 32 kilometers. I'm going to write it in this form, hours per second. And in this case, what I need to convert is kilometers needs to go to meters. And then you've got these two time units. One is already in seconds, so I can leave it alone. I don't have to do anything to it. The other thing I have to do is I have to convert this to seconds. This second is fine. You can leave it alone. Just leave it until the end. So I have two conversions to do here. So I'm going to need two conversion factors. Let's deal with kilometers first. Kilometers is in the numerator, so if I want to get rid of it, I need to put it on the other side in the denominator. And I want to go to meters, so that will be up in the numerator. And we know that the 1 kilometer is 1,000 miles. In terms of hours, I want that to go to seconds. So hours is in the denominator, so I need to put it in the numerator. And seconds, my desired unit, is in the denominator this time. And 1 hour is 3,600 seconds. So go ahead and do that math. So 32 times 1,000 divided by 3,600. Get 8.89 meters second squared. Okay, practice problem number 2. So we're given an acceleration. If my car can accelerate at 12 miles per hour per second, how many minutes will it take for my car to speed up from 16 miles per hour to 40 miles per hour? So A is 12 miles per hour per second. How many minutes, so that's a question about time, will it take to go from 16 miles per hour, V1, to a V2 of 40 miles per hour? Okay, I'm going to pause. You go ahead and solve this problem. Okay, so you're back. You've tried it. Again, I'm going to use the equation that we've been using. A is V2 minus V1 all over T. I'm solving for T, so the equation really becomes T equals V2 minus V1 all over A. If we look at our givens, we have units of miles, and then we have units of hours and seconds. When I go ahead and just plug in to this equation, T equals V2 is 40 minus 16 V1 I don't have to do anything with those units because they agree. I can subtract them. They're both miles per hour. But when I go to divide by acceleration, I've got 12 miles per hour per second. Let's look what happens to these units. First off, this top part becomes 24 miles per hour divided by 12 miles per hour. I'm going to pull 1 over second out here. So I'm rewriting that unit because I want you to see that this unit is the same as this unit. So they cancel. And I will be left with 24 divided by 12. And I'm going to get 1 over a second as my unit, or that's 2 seconds. Because this down here is really 1 over, because it's in the denominator, 1 over a second. Now, the actual problem asked to figure out how many minutes this is. So the last step is to convert 2 seconds to minutes. So 2 seconds times 60 seconds is 1 minute. So 2/60 of a minute. To divide by 60, 0.03 minutes. So this is an example of what you could do with a problem with funny units. I'm going to do one more sample problem. I'm driving a car at 18 meters per second. The car can decelerate, that's negative acceleration, at negative 4 meters per second squared. So how fast would the car be moving? Oops, how fast would the car after 1.5 seconds? So go ahead, take a minute, pause the video, solve it yourself, and then come back. Okay. So in this case, our units are all fine. Meters per second, everyone's in meters, everyone's in seconds. The reason I put this on here is I want to make sure you can solve for V2. So V1 is 18. V2 is our unknown. A is negative 4 meters per second squared. If you're having trouble in the language of the problem figuring out what is speed and what is acceleration, look for the unit. Acceleration always is seconds squared, or has 2 time units, hours and seconds, versus velocity just has 1 time unit. And we're told we have 1.5 seconds. So in this equation, V2 minus V1 all over t. I'm going to solve for V2 in this case. So to isolate it, first multiply through by time. So those cancel out. And I get A times t equals V2 minus V1. And then I'm going to add V1 to either side, and that will leave V2 all by itself. And so this equation becomes V1 plus AT equals V2. So I'll bring that over here. V2 equals V1 plus AT. And now I can plug and chug. V1 was 18 plus acceleration, which is negative 4, times the time, which was 1.5. I believe this will give us 12. One note here, conceptually, what's going on? We're decelerating for 1.5 seconds. The acceleration is negative 4 meters per second squared. So each second the car loses 4 meters per second of speed. So we have 1.5 seconds to lose speed. So in the first second we lose 4. In the next second we lose, or the next half second we lose 2 for a total of 6. So in first second, lose 4 meters per second. In the next 0.5 seconds, we lose 2 meters per second for a total of 6, and that's how you go from 18 to 12. And this is the end of the video.